citizens, back with me again, Jiga Utama Putrada. I am a lecturer for Operating Systems course. This is our fifth meeting about concurrency case study. We have reached the last video. Here in this video, we are going to discuss about semaphore for problem 1 and 2. Stay tuned. So we have discussed in the last video, we have discussed how semaphore tackles solve the problem 3, and now we are going to discuss the rest. First, we are going to discuss about how semaphore solves problem 1, which is don't consume and produce at the same time. Now in this example, the story is the consumer producer problem is not in initial state, it is in the middle of a process. Here we can see that the buffer is half filled. It has reached 2 members, so here I equals 2, and then the producer will run same weight full, which will change the full value. It will be decremented, so full now is 2, and then same weight s, so s is also decremented to 0, and then produce, and then interruption happens. Here consumer runs, it runs same weight empty, so empty is decremented to 1, not blocked, and then same weight s. What happens here? S is decremented to -1, which is a negative number, so consumer is blocked. Consumer is blocked, it cannot run, so the process is turned back to the producer. Here the producer fills the second member with the produced number, which is 1, and then I is incremented to 2, to 3, and then same signal S, so S is incremented to 0. Because this is 0, a blocked process is unblocked, so this is unblocked, and consumer can run again, and then it decrements I, and so because I becomes 2, and then take, so it takes the last number here, and then consume, nom 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 nom, the consumer consumes the number that it has just taken, and then after that what happens, it is up to the rest of the program. So this is the last example, our third example here. Example 3 is the solution of the last problem that has not been solved, which is the second problem. The second problem is the producer cannot fill a full buffer. So here we created a problem where the buffer is already full. The I is 5, and here we can see the buffer is full, and the S is equal to 1, the full is equal to 0, and the empty is equal to 5. Here we will see what happens. First, the producer will run same weight full, so because same weight full, full is decremented, it becomes -1. So here the producer is blocked, and in exchange the consumer will take place. So same weight empty, empty is decremented to 4, which is not a negative number, so it will continue. Same with S, S is decremented to -1, to 0, which is not a negative number 2, so it will continue. I is decremented, it becomes 4, and then take, which means consumer will take number 1, and then consume, nom 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 nom, and then same signal S, S becomes 1 again, and then same signal empty. So here, same signal full. So here full becomes 0, which is Q for the producer to be unblocked, because 0 means unblock a process. So here block the producer is unblocked, and then the producer will continue. So same way S, the S becomes 0. It means that consumer cannot run, and then produce one number, and then fill. It fills the fourth member of the buffer. So before it has been taken by the consumer, here it is filled again, and then in command I becomes 4, 5 again, and then the rest is up to the rest of the program, which is random and we cannot predict it. Here we can see that the semaphore prevents the producer from filling full buffer. So that is the end of our last video. We have successfully discussed that Semaphore can solve the consumer and producer problem. I'll meet you in the next meeting where we will still discuss about concurrency. Thank you for your attention.